This video will cover the addition of organometallic reagents to ketones and aldehydes. Organometallic reagents include both Grignards and organolithium reagents. Both of these react similarly with ketones and aldehydes. In both of these types of reagents, carbon is a nucleophile, and ketones and aldehydes contain a carbonyl, which is a very good electrophile. The general mechanism for an organometallic reagent reacting with a carbonyl looks like this. The organometallic reagent has carbon as a nucleophile, carbon with a lone pair of electrons and a negative charge. It reacts with the carbonyl electrophile by directly attacking the carbon of the carbonyl. This carbon can't have more than 4 bonds, so the pi bond to oxygen leaves to join oxygen as a lone pair. We have seen similar intermediates in the past. They are called tetrahedral intermediates. The new bond is between the R group that came from the organometallic reagent and the carbon that used to be the carbon of the carbonyl. The final step of most organometallic reagent reactions includes the water workup step to protonate the alkoxide ion that is formed. This produces the product alcohol. The synthetic scheme for making and using a Grignard reagent to react with a ketone or an aldehyde is typically 3 steps. In the first step, we have to synthesize the carbon as nucleophile, either the Grignard reagent or the organolithium reagent. An example of this is reacting ethyl bromide with magnesium metal in ether, which produces the Grignard reagent. The next step is when we react the carbon as nucleophile, either the Grignard or the organolithium reagent, with our electrophile, our carbonyl containing compound. For example, we could take the organometallic reagent we just produced, the Grignard reagent, and react it with a ketone. Again, in the presence of ether to stabilize the Grignard reagent. This produces the tetrahedral intermediate, the alkoxide ion. The final step is the water workup. In this step, we protonate the alkoxide ion to produce the alcohol. Additionally, this water workup quenches the remaining organometallic reagent. It is important to note that these 3 steps must be carried out sequentially. We can't have water present in either of the first 2 steps, or the organometallic reagent that is formed will react with water as a base rather than our electrophile as a nucleophile. Finally, let's look at some examples. One of the good electrophiles that we can add organometallic reagents to is formaldehyde. Remember that formaldehyde is a special aldehyde that has no carbons attached to the carbonyl carbon, only hydrogens. When we add a Grignard reagent to formaldehyde in the presence of ether, followed by a water workup, the product is a primary alcohol. No matter what organometallic reagent we add to formaldehyde, the product will always be a primary alcohol. If instead we add our organometallic reagent to an aldehyde other than formaldehyde, such as this one, again in the presence of ether followed by a water workup, the product will be a secondary alcohol. Finally, if we add our organometallic reagent to a ketone in the presence of ether followed by a water workup, the product will be a tertiary alcohol.